start our new unit, okay? We just finished up with polynomials and graphing polynomials and solving polynomials and factoring polynomials, dividing polynomials. And we're going to move on to our next unit, which is radical functions, okay? We're going to deal with radicals. And they are functions. They have a graph. If you remember back when we did our dance at the beginning of the year, radical functions had that function. Remember that? You probably don't remember, but it looks like this. That's the shape of the graph. Okay, and so we have radical functions. That's the square root function, square root of x. But radicals come in all different kinds of, they have all different kinds of indices, we call them. The number that's out here, and if there's not a number, we all automatically assume it's a 2, right? Square root, the square root of whatever. But we can have a cubed root. We've seen that before too, haven't we? And there's fourth root, there's fifth root, there's all different kinds of them. Okay, and they had different graphs and whatever, and we're going to be solving radical functions and all kinds of different things. But today, we're going to spend time just reviewing how to reduce radicals, okay, some basic radical functions to reduce. And you guys are going to have a classwork assignment, and then we are going to spend time making up stuff. Okay, that's kind of our gist for today. Let's start with some basic radicals, okay, and we've kind of alluded to this before, but if I had the square root of 100, what does that reduce to? 10, and we know that. Our calculator will even do it for us. If you type in the square root of 100, it comes out exactly as 10. Now, remind me, if we did a factor tree, remember how we talked about this before, what two numbers go into 100? 10 and 10 are our obvious ones. If you can get a pair that are exactly alike, that's great. And we can actually stop there. We have a pair. There's nothing left over. The answer is 10. Now, if you guys also remember, we don't have to use 10 and 10. Anybody think of 50 and 2? Anybody think of that? This will work also. 2 doesn't reduce anymore, so we'll just bring it down. But 50 does. What does 50 reduce to? 5. There's options. It doesn't matter which option you pick. I first heard 25 and 2, but 5 and 10 work just as easily. So if we said 25 and 2, all right, we're looking at what does reduce. Well, the 2's don't reduce. We'll bring those down, but 25 does. What does 25 reduce to? 5 and 5. And those are what we call prime numbers. We can't reduce them any further. We're done. We have a pair of 5s that come out, a pair of 2s that come out, and so we would say 5 times 2, which happens to be 10. So either way you did the factor tree, as soon as you get a pair, you can bring it outside of the radical. Now, I say a pair because what is the index that's out here? Isn't it a 2? Okay. So whenever you don't have a number there, it's assumed to be 2. And that's what we're going to work on today, mostly just reducing radicals with an index of 2. Soon, we'll be looking at an index of 3, okay? For example, if I said the cube root of 27, well, just real quick, if we said 27 did a factor tree, what are some numbers that go into that? 9 and 3. 3 is prime, so we'll bring it down, but what about 9? 3 and 3. And since the index out here was 3, in other words, since this number here is 3, what do you think we're going to be circling? Not groups of 2 anymore, but groups of 3. So since we have 3 3s, that's a coincidence, but we have 3 of them is what the point is. What do you think the answer to this would be? Just 3. We circle one group of 3. There's nothing left over, so the answer is simply 3. Now today we're going to be working with just an index of 2, okay, just square roots, but they get a little bit more complicated. What if I said the square root of, I'm just kind of come up with a number here, let's just do 50, square root of 50. Okay? If I typed in the square root of 50 on my calculator, you can try it now. You're not going to get an answer that's exact, but go ahead and try it. Tell me what you would get. What decimal equivalent approximately is it going to be? What'd you get? 7.07, and it goes on, right? Okay? So it's not an exact number, which means the calculator's not going to reduce the radical for us, okay? So we would have to do some work over here. So let's make a factor tree, okay? And what numbers do you see? What numbers did we use before? 5 and 10? Sure, we'll use different numbers. 5 is prime. but 10 isn't. And what do we have? 5 and 2. And we're looking at a pair because the index is 2. We do have something left over, so I'm going to use a box for it. I'm circling groups of 2 again because my index is 2. What number comes outside of the radical? The 2 or the 5? The 5 does. So 5 comes outside, and there is something left over, so there is something that stays under the radical, and what would it be? 2. Good, and that's my answer. Type into your calculator 5 radical 2. Make sure you get 7.07 whatever. Did you? So you have a way to check your answer, don't you? You know, if I type the original one in, and I type what I think the answer is, and I get the same decimal, I did it right. Okay? Now, it gets a little harder, as you can imagine. Okay, we did this back in pre-algebra probably, right? What happens if I throw some variables in? For example, the square root of 25x squared. How does that change things? Well, why don't we deal with the number first, okay? The square root of 25. What does it reduce to? 5. If there's nothing left over, would you agree? If I did a factor tree of 25, we would simply have 5 and 5. We have a pair with nothing. Great. So the 5 comes out. What about x squared? How do I write that? If I wanted to make a factor tree of x squared, how many x's would that be? The x times x. And what am I looking for? Pairs. So I have a pair. Is there anything left over? So what does that mean this reduces completely to? 5x. All right. Variable freak you out yet? You sure? What if I said the square root of 27x to the 4th y cubed? This is about as hard as it gets with the variables, honestly. Okay? So what will we do here? Let's do the numbers first. Is the square root of 27 a perfect square? If I type it into my calculator, do I get an exact number? You shouldn't. So we're going to need to make a factor tree, right? Let's do a factor tree of 27. What do I get? 3 times 9, okay? I think you're jumping ahead, okay? So we have 3 times 9. 3 is prime, 9 is not. 3 times, what's the factors of 9? 3 and 3, all right? And I'm down to my prime numbers. I'm looking for a pair, which I have a pair, but I have something left over, don't I? So the pair comes out, and I have something left over. I have a 3 left over, so it stays under the radical. We're good so far. Now let's deal with the variables. If I said x to the 4th, which I am saying x to the 4th, I'm going to write 4 of them down. You good with that? And what am I looking for? Groups of how many? So I'm going to circle pairs. How many pairs of x's do I have? So this is just x squared. Is there any left over? So there's no x's left underneath the radical. Let's deal with the y's now. How many y's am I going to write down? Okay. And what am I looking for? Pairs. How many pairs do I have? So 1 pair comes out. Are there any left over? Yes. So that stays under the radical. There is a shortcut to this, but I think it's really important to see the visual of circling the pairs and understanding why the numbers are the way they are. Are you interested in knowing the quicker way? Or some, it's not quicker for some. I like this. I like to circle the pairs. But you can also do it this way. What did we say the index was? 2, right? What's 4 divided by 2? 2. That's why it's x squared. What's 3 divided by 2? 1, which is why you have a power of 1 on the y. But how many are left over with 3 divided by 2? The remainder is 1, which is why the remainder of 1 underneath. The quick way is to take this and divide by this. If it divides evenly, everything stays out. If there is a remainder, for example, 3 divided by 2 is 1 and 1/2. Remainder is 1. 1 comes out, 1 stays underneath. If you don't like that way, write them all out and circle pairs. I'm good with that. Okay? All right, so what else could I add to this as a review? Did you do it with the variables last year? You did the variables before. Okay, good. So it's all reviewed to this point. Excellent. The only other thing that I could see I could change up would be something like this. The square root of 2 times the square root of 50. I could also say the square root of 2 plus the square root of 50. Okay? How would I solve either of these? Now I'm multiplying things. Let's start with the left-hand side first. You can multiply anything. They don't have to be alike at all. I just multiply what's underneath the square root. And if there were numbers in front, I'd multiply them too. But there's not here. We'll look at one where there is. So what is 2 times 50? So what's the square root of 100? The answer is 10. Could you check it? On your calculator, type in square root of 2 times square root of 50. See if it doesn't come out to be 10. It should. Does it? Make sure you're doing them separate now when you don't write them all. The radical doesn't go all at once. So the square root of 2, come out of it, times the square root of 50. You should get 10. The only other thing that I could do to make it even more difficult would say something like this. 3 square roots of 2 times 4 square roots of 10. What would I do here? Well, I multiply the numbers out front and the numbers underneath and then reduce it if I can. What's 3 times 4? So that's what I multiply. You multiply the kind of like the numbers out in front. So 3 times 4 is 12. What's 2 times 10? Okay. Can I reduce the square root of 20? Yeah, so here's where we're going to do a little side work. How do I reduce the square root of 20? Give me some numbers that go into 20. 10 and 2. 2 is a prime number, so we'll bring it down. How about 10? 5 and 2. Circle my pair, because we're doing the index of 2. And then the 5 stays underneath. So 2 radical 5. Well, there's already a 12 there, though. So 12 times, what number did I bring out? Okay, 2. And then what number stayed underneath? Okay. So this is just 24 radical 5. All that work. Okay. And we could check it if we needed to. We could say 3 square roots of 2 times 4 square roots of 10 in a decimal. And then we'll try 24 square roots of 5. We should get the same thing. Okay? The only thing you have to be wary about with the calculator and checking it is make sure that what's underneath the radical is reduced. Because if you typed in 12 square roots of 20, you'd still get that same decimal. But it wouldn't be fully reduced. Okay? So make sure you're reducing everything. And if there's an x or a y, that can complicate things too. But I'm going to show you a shortcut when it gets closer to the SOL for that, but not till then. What do you think on the right-hand side? Can I add anything I want? Could I add x plus y? They're not like terms, right? So unless they're like terms, I cannot add them. Right now, are they like terms? No. So are either of them reducible? Square root of 50 reduces, doesn't it? So let's try it. How do I reduce the square root of 50? Make a little factor tree. 10 and 5. 5 is prime, so we'll just bring it down. How about this? How about 10? 2 and 5. Do I have a pair? And I have something left over. So how does the square root of 50 reduce? 5, square root of 2. Very good. Now, are these like terms now? How do I tell? They're like terms if what's underneath the square root is the same. It was not the same in the beginning because one was a 50 and one was a 2. But now that I've reduced the square root of 50, is what's underneath the square root the same? Yes. So in order to add these, I only add the numbers in front. You treat them like an x, like 1x plus 6x is 7x, right? So I'm going to leave my answer in terms of the square root of 2, but what's the number in the front? 6. 1 plus 5. So that would be my answer there. Okay? You could check it too. Square root of 2 plus the square root of 50. We get a decimal, that would be 8.49. And then if we try 6 square roots of 2, we should get the same thing. Okay? So you can always check your answer. So again, when we multiply radicals, you multiply both the numbers in the front and underneath. When we add radicals, we can only add them if they're alike, and you only add the numbers in front. That's the main difference between adding and subtracting. Okay? All right. So this should be mostly a review for you guys. I think adding and subtract, or adding and by the way, if it was subtracting, could you do it? Would it just be like 1 minus 5? That's okay too. All right, so I'm going to go ahead and give you some problems to work on. Once you're done with those, I'm going to come around and tell you what, if you need an OPQ to make up or a test to make up or whatever. But this is really all we're going to be working on for today. We'll get into the meat of it on Thursday. Okay?